Srinjoy Bhuiya, who is a MyText research intern, a technical associate at Ajantric. He's a published AI scholar with research papers to his name and an ex-computer vision lead at his startup Tivra AI. Over to you, Srinjoy.
Thank you for that generous introduction. And okay, so can I get the sharing option? Is it available? Like screen share?
I think you might be able to screen share.
Okay, perfect. Okay, so like what I'll be doing today is basically working through some stuff which is not taught, like not even talked about much in the regular those popular internet courses. Like people start with the scikit-learn and TensorFlow. So I'll just go a bit deep and try to understand that why are we using those models, and what is like how can you correlate what data you have and what models you are using. So that's it. I'll just start the screen share. Just give me a moment. Yeah. So the like my the name of the session is Hidden Basics of ML, and as I just told you all, like there will be some things which many courses don't talk about, and we would be like talking about those exact strategies of how to start your model learning and model building. So like Shohardo already gave all this, which I've wrote like or like it's on the slide. So I'll just talk about what I have been doing at these different places. At Tivra, we were working on making a semi-autonomous like an ADAS sensor. So basically, what it does is it connects to your car and it tries to make driving easier. Like certain technologies like lane switch assist and parking assist, which can like which are not completely autonomous driving, but they assist you in making driving a little less severe on your day-to-day lifestyle. So that's it. And we were working mostly in the computer vision domain there as well. Like most of my work is in the like in that domain, and so that's what I'll be focusing mostly on in this session. And I am also doing a work in biomedical images, which is basically detecting retinal like diabetes and all like other kinds of diseases which can be detected using a scan of your like retina. So what we do is in those projects, what we do is we use something we use some like models called autoencoders, which I'll be talking about a bit later. And currently I am like a part of the AI team at Ajantric, where we work on warehouse automation, and there we develop smart bot assistants which make the moving of goods in a warehouse much faster and much more efficient by using some algorithms like pathfinding algorithms and some more of computer vision as always. So now why should we learn the basics? Now, like as I was mentioning, a lot of ML enthusiasts start their ML journey like using tools like TensorFlow and scikit-learn. Now, those are obviously beneficial because they save a lot of time. But what they also do is they make the entire work of using machine learning like a function. Like you have a function, you don't know what is going inside the function, and you just apply that. Like how many people like how many of you all have some knowledge or like prereq knowledge about ML? Can you all just speak up or raise your hands or something? Okay, so there's one there. So basically, there are some models in classical ML like SVMs, and there's another called logistic regression. So they are both defined in this library of scikit-learn, which is a Python library, and they can be used like wherever one can be used, the other can be used as well. So like many people don't focus on why should we use SVM and not a like some other model. So like this you have to understand by looking at the data and trying to understand what the caveats of that particular model is. So like for those kinds of works, we'll have an example later in the session where we'll talk about how this like how can you analyze the data and like and choose which model you'll select. Like you just can't throw everything at a particular problem and just trust that machine learning will do its job. That like it's more of an art than a science. You have to understand, and you have to like live with the data for a few days and then continue working on it. So now let's start with a concept called the learning problem. As you know, this entire field is called machine learning. So what is learning here? So learning is based on the fact that there should be three essential factors in the problem statement that we have. So we should have a particular pattern in the problem statement. We should have enough data on it, and we should have like a problem statement which you can't find a exact mathematical answer to it. Like suppose you have a function which calculates the square of a number. Now that you shouldn't use like machine learning or deep learning techniques in that, because you already know the function. You should always use machine learning in like situations where the exact mathematical model is not known to you, and there, like in those situations, it is much helpful. So now let's start with some mathematics about the entire problem. If we can show that the input to a model, like basically you have some model and you have to give some basic data to it, and then the model will output you some result. Like the input might be, suppose, your age and your salary, and where do you work, like are you a businessman, or are you like working as an architect or an engineer, those three fields. And the output is, shall I give you a loan or not, or are you a, like if you take money from me, will you like give that give back that money to me. So that might be your output, and those three data might be your input. So those we are referencing by using x and y variables, which are commonly used in maths. And we are trying to find this function f. This function f is basically our, like this is what we are targeting, like we want to find this function. However, the problem is that obviously, because this problem is much more difficult than a simple math equation, we don't know this exact function. So by using data, we would try to find out, we would try to back calculate what that function might probably be. So as you can see, we have multiple sets of data, like x1, y1, x2, y2. We continue till xn, and these are also known as historical records of the particular, like the problem statement we are trying to solve. And then we try to come up with another function called g here, which is the actual function, like, or the mapping between the new x value, like values, and new y values that we will find later. So we will try to map a function from x to y such that on new x and y variables, such that we can copy what the target function f will be doing. So this is how we try to understand or formalize the problem, because obviously you can't, sorry, you like obviously can't think about a problem without breaking it down into like mathematics or stuff you can understand it. So we'll basically break it down into simpler concepts, like having data and mapping a function. So now this is how the entire journey of like a problem would go. You start with this target distribution, which is basically the target function of f we were talking about previously. So we need to find what that is, but we never can understand what is that for sure. Like even if I give you a million data samples, you'll be never be able to understand what exactly that is. So you need to somehow guess or make a educated guess about what that will be, and that educated guess is your function g. Now how will you understand what is this function g? You will take some training samples which we were defining by x1, y1 to x and y, and then we'll use a learning algorithm to to calculate the, or to find out the final model which you want. Now this model will obviously need to be, like, we need to measure that if the model is good or bad. So we use something called an error measure, which basically measures the difference of, like, the quality or the difference of the results between the target distribution or the training sample distribution and the final model that you have. So suppose you have a credit application, as you were talking about before, and you have a person called, suppose, Ram, who has a salary of 10,000 rupees, and he works as a, let's go, like an engineer or something. And we have another guy whose name is Sham, and he has a salary of 5,000 rupees, but he's working as, let's say, a waiter. So now, and the result of the answer, will the person be able to pay back the loan? For Ram is yes, and for Sham it's no. But however, the model which you generate later gives you the opposite result. It says ki Sham can give you back, give back the loan, and Ram will not be able to. So therein lies the error between this point, like the actual distribution in the data and the your model's answer. So you need to calculate that using some error measure. Now those can be of multiple different varieties. Some popular terms people might have heard is called binary classification error, then mean squared error. So those are those error functions are basically you give them a x and y and value, and then you try to calculate if it is similar to what the data wanted for that particular value. Yeah. And so we move on. Now, there is another important point of deciding what kind of complexity your model will require. Like suppose there are models such as regression, then support vector machines, then binary trees, and then artificial neural networks. So now the level of model complexity is different across all these different models. So now which one should you choose for which particular problem? Now, this graph has been taken from a very popular course on machine learning, which is the Stanford's not Stanford. This is the Caltech course of machine learning. So, I am using a lot of their graphs. So, thank you for that. Thank you to Caltech for making that free for all of us to use. So, what this graph is telling us that for a given model complexity and for a given data set, there is a Goldilocks region which exists somewhere at a point where the out of sample error, means the testing error, is the lowest. The model complexity is somewhere a middle value, and the training error is also at its not its lowest value, but a good low value. So if you are increasing the model complexity, and even if your training error goes down, your testing error will keep on increasing. So that doesn't help anyone. So there is a strong, a direct correlation between model complexity and your testing error. So you should always choose the least complex model which can sufficiently map the problem you're working on. Like if you suppose take an ANN and you want to map a function, suppose like a XOR function. So that is not required because an ANN is much more complex. You can use something, a simpler model to do that exact same problem. So now let's understand that how can you think about what a model can do and not do by using a simple model called PLA. Now the PLA was a model developed in the 1970s by someone called, I think, Rosenblatt. I think he works in the US, some Stanford or Caltech. Now, so what he discovered was he discovered a method of classifying data between two given classes. So you have, and the data has two features. Like suppose the feature one, which is given in the x-axis here in this graph, and the feature two is given in the y-axis. Suppose the feature one is how much the person earns, and the feature two is what's his age. Okay, so given these two data points and the class, you can classify these two into two different classes, like those classes previously were, like can we give him a loan or can we not give him a loan. So now, as you can see, this perceptron model tries to draw a straight line between these two classes. Like it will never draw a curved line. It will always try to draw a straight line. So what does this model assume? This model assumes that these two classes are linearly separable. Like you don't need a complex classification boundary. You don't need a convex a boundary or a concave boundary. You always need a linear boundary. So now, obviously, there are some benefits for using this model. That is, it is very less computationally complex. It just takes a fraction of time to calculate this, to get a decent enough model. But however, there are also some demerits. Not all data is completely linear. So how this model works is you have basically suppose here is given 3 data, but you can work with n number of variables, which are your input data, and you feed them into a model which will try to calculate that if it is this class or this class. This is the output. This y hat is the output here. So now you have some like some weight values, like have you all seen a graph, right? A graph in CS, guys. Anyone can, if they can respond with raising their hands up if they have
Yes.
seen or heard about a graph. Okay, perfect. So now in a graph, what happens is you have some weights to the edges. Now these are that kinds of like weighted graphs. Okay, so then you have some input data, which is can you can think about like those the nodes value. So now what this does is it tries to multiply the weight of the edge which it connects and with the data, and it multiplies them and it sums them up. And suppose for person X we get here age 21. Let's go with two variables only, I'm not counting the third variable for simplicity. Suppose you have age 21 and salary 10,000. Now obviously, like salary will play a much more important role in deciding whether the person will be given a loan or not, or will he be able to repay a loan or not. So this theta 1 will be increased to make the model pay attention to that particular detail. So and then we multiply them all together, and then we find a particular value where we will say if this sum is more than suppose 10,000, then he can pay back the loan, or if it is less than 10,000, he will not be able to pay the loan. So that number is completely like we don't decide that, that number is like checked by the model. And that is how the learning will, that is the point of learning, that you want to find out at which particular value of the threshold you want to classify it between. Yeah. So like I'll just go to another slide here, which is not in this PPT. Just give me a moment.
Srinjoy, you are muted.
Oh, like y'all can see my screen, right?
Yeah, we can see your screen.
Okay, perfect. So now, like as I was talking about the perceptron model, so now what that like how do you find out that line? So that line is essentially found out using the sum of the weights of the nodes and the weights of the nodes and the weights of the edges. You multiply them here, and then you sum them up together. This part. So now there is some threshold which we were talking about of how to, like what is the exact point where you will say that that point, above that point is you are going to say them that it is like you're giving them the loan, and below that you're not giving them the loan. So now how to make it into a class? So now if we can, if we think of this sign function like as a point, if it is plus one, like if it is, suppose this sum of the value is 10,005 and the threshold is 10,000, which is like obviously given by the model which like it will train. So if the sign of this is suppose -5, then the sign will be -1. So then that is one particular class, that -1 is one particular class, and if it is positive, then it will be another class. So that is how the model tries to classify the different data. So now this sign function is like has some of its benefits, like at which point like it gives us a definite point at which we will classify. It's not a soft threshold, it's a hard threshold. So it doesn't have those problems which occur later in ANNs where there are soft thresholds by using a sigmoid function or a smooth curve function. A sine function is obviously a very hard function. Like at zero, it is there's a straight line, and at minus like behind zero, it's -1, and above zero is +1. So it's a very hard function. So that is one benefit of using this model. However, if you would have noticed that one disadvantage of using this model is, suppose we are taking this point, which is, suppose we're taking this point, this bottom right point, which is, suppose we're taking this model which is this bottom right point, and we are trying to check that if it is correctly classified or misclassified. Using this line, we can say that it is obviously being misclassified as a negative class. And so how do we try to correct this in the next walkthrough of the model? So we'll take the difference between the line, like obviously there's a Euclidean distance between the point and the line. We'll take that distance and we'll subtract that distance from the sum of the products, like from this value, from this summation value, we'll subtract that distance. So the line will change into something like supposedly this. Okay, or let's give a better example. Suppose the line will change into something like this. That's a bad line, but this side would be plus and this side would be minus. However, now this point is misclassified. So this is one inherent problem of this kind of a model. Like since the threshold is so hard, the moment, like it will never, like there will always be some points which will be wrongly classified, and it will never give us a happy middle point. Like suppose it will not generalize perfectly, because obviously we can't have a curved line here. Like, my drawing skills are not particularly good, so I'll just use a shape tool, something like this would have been a problematic line, and the perfect line which we would like wanted would have been this. Suppose like this. So this is not possible from this perceptron learning algorithm. Hmm. Okay, so I'll just go back to my slides for a moment. I'll just okay. So now, as you saw, that one perceptron can classify anything which is completely linear. Now, how can we extend this logic of calculating linear boundaries to non-linear boundaries? Do you all have any idea? Like suppose you have one line and you can only, like you have one line, you can classify the left side is something and the right side is something. Like how do you make, like how can you use another perceptron model, like two perceptron models, and make it a non-linear separable data? Like can you all think about that for a second and give me an answer somewhere?
We can check on the point is lying on which side of the line. If
Yeah,
we are
surely. But suppose you can't get, like we want all of our, at least our training points to be like classified correctly, right? Suppose there are no linear lines which separate the data perfectly. So can you use the perceptron algorithm more than once or perhaps thrice or four times to make that a non-linear boundary? Can you think of some adaptation of this model? Okay, so what we can do is we can take two such models, and then one would be suppose a vertical line which was shown in the image, like in the slide previously. Like one would be like a line like this, and one would be a vertical line if it is not linearly separable, and we can take another line on the left side. So then the entire classification boundary becomes a kind of like one edge of the square, like three edges of a square. So you can take multiple perceptrons and you can combine them into a much more complex boundary. So that is what were the foundations of using an artificial neural network. A perceptron is nothing but a linear classifier, and if you add multiple perceptrons to a model, you will like come across something which is similar to a modern day artificial neural network. Not the similar thing, because modern day ANNs use some other, not a straight line, but they use something like a logistic or like a sigmoid function. But here we can, like you can combine multiple PLA models and form a ANN model. So that's how it is, like the ANNs came about. And so like this perceptron, then logistic regression, then came about ANNs, and then CNNs. So that is how the field has progressed throughout the last 30 years. So now let's go into some like more. This was a very like this model, this PLA model was described in the 1960s, and it was not regularly used in the like till the late 2000s, because there was not enough computation available to process like data in huge numbers. But by that time, much more better models came about. So let's go ahead and look at some of this. So like this model is something which I was like using in like active development from like the last 1 or 2 years, and this uses many features which are currently used in today's industries, so we can like talk about this of like some time for some time. So like how many of you all have heard about encoders and decoders in college or like school time? Like something,
Yes, I have heard.
suppose like you all have like 2 to the power n lines, and then you like encode it into n lines or something like that. So like modern day ANNs, like artificial neural networks, what they try to do is they take like a huge data, like suppose like one sample has suppose 15 columns, and like there are thousands such samples. So that is a very large data, and you try to get like suppose only 1,000 values, but only one value for that. So what you are doing is essentially encoding the data into a complex feature. Like you have raw data and you are trying to encode it in something which is much more usable for us. So that is like a encoder, but it's a machine learning encoder. Now that is something which will be very beneficial to us, because mostly in most cases of computer vision, sometimes what happens is you have like an image. So an image is suppose how many pixels, like 500 by 500 pixels. So now if you take that 500 by 500 pixels image and then you feed it directly into a model which gives us the output of, suppose if it's a cat or a dog, then it will take intense computational powers. Like you saw, right? You have to do multiplications of 500 into 500 times with 500 such weights. So how much time will that take? So rather than doing that, what you can do is you take that 500 cross 500 image, then you pass it through a like an ANN encoder or CNN encoder, like a convolutional encoder, and then it transforms the data into much more manageable size. Like suppose the input was a 500 cross 500 image, then you transformed it, or you change the features into a smaller, suppose 7 into 7 like vector, and then you apply whatever machine learning or deep learning model you want to, and then you find out if it's a cat or a dog or suppose some other animal. So this is done only to save some computational resources, and this kind of thing is called an autoencoder or an encoder decoder architecture, where the encoder converts the raw data into something much more workable, and then the decoder is the part which does the actual classification. So this kind of an architecture is used heavily in today's machine learning or like workloads. So you all can like look this up, and this is a very popular like a research field currently. Also, one more thing which is currently very like in hot demand is something called attention networks. Now it's not that like the graph is looking very intense, but it's not. What this image is trying to do at the bottom is basically, suppose you have a similar a 500 plus 500 image. Now suppose that image is of a cat, and there is another class which is of dog. So what is the particular difference between a dog and cat? It might be the whiskers or it might be the eyes. So now like when we feed it into a normal CNN or a normal neural network, then it will take the entire image with the same amount of information. Like it will give the importance to the entire image, the same amount of importance. So now, however, attention models, what they do is they will check, okay, so this part is the most varied between images. Like between a cat and a dog, the face, the part of the nose or the part of the whiskers is the most important. Like dogs don't have whiskers and cats might have whiskers, so then that part will be given more attention. So that is done using some complex movements of, as you said, like some different encodings. You encode it different ways, then you do some like matrix multiplications in the middle, and then the result of this calculation would be that the weights of the model will be like given more importance at those certain areas, and the other parts will obviously be like will be given some attention, but not that much. So this thing is called an attention model, and it is used in many different fields, like not even in images. It is used in places like, suppose, natural language processing. Like in those fields, what they do is, suppose you have a sentence like, I met a person on the road. So now the importance should not be on I or on, it should be on person, road, met. So there are the importance is more on those words. So similarly, these attention models, they just look for where to give much more like importance to for the model to generate the output function or to generate the hypothesis function. So these things are like, this is three different ways of doing the same thing. Like you can either do it through this kind of a model where the entire feature vector is converted into like one line, like one node takes it the same image vector and another one converts it in something else, and then we do some other calculations here. Like obviously it's not clear by my such like high level uh, like walkthrough, but what these try to do is they try to do the same thing of like finding out different weights between the two different parallel paths, and then we try to multiply them together to join those important features together. And this is how it's done in three different ways. Anyway, so like what my model was trying to do is, it was trying to create a segmentation model. Means basically, suppose in an image, where is, suppose it's an image of a house, and where is the door, in which exact pixels is the door. So that is something which is a segmentation model. And these are like, these kinds of tasks heavily use autoencoders and attention mechanisms. Yeah. So and the one more benefit of using attention models is it like reduces the inference time of the model by a factor of 10 or a factor of 20. So that is one benefit of using such like recent advancements. Yeah, and these are used in the fields of medical research and obviously autonomous driving. I have like, since those two are the fields I have worked in, I have some experience, so I have given them. Yeah, also another important model which has been quite famous in the current few, like the last few years, is something called generative adversarial networks, or some people call them GANs. Now, this was developed by a person called, I think, Ian Goodfellow. I'll just check. Yeah, like he was the guy who discovered this, Ian Goodfellow, and he is currently, I think, in Canada, and he's continuing his research there about this topic only. So what the main point of using a GAN is, basically, suppose you want to generate some images. Like, have you all used Prisma before? It takes an image, then it generates a completely, not a completely new image, but a stylized image of this of the like your or like the object with the same image. So that is essentially, for the computer, it is generating a new image only. So what it does, it maps a function which takes that your raw image and it converts it into something which is like, this is the fake image which is generating, and it tries to find out the similarity between the real images and the fake images which is generating. Like that is sorry, like that is why your images from Prisma or those kinds of like apps are so similar to the original image. Like they are passed through a model which say that has it crossed the threshold of being similar enough, and that is how the model learns of to make like generate new. That's why it's called generative networks, because one model is trying to predict if the real and the fake images are similar or not, and one like model is trying to generate those fake images from just random bits of ones and zeros and such. So now there are some things which I would like to tell like new prospective learners of this field to do is don't start with like directly implementing something on PyTorch or TensorFlow or scikit-learn. Try to do it using simpler systems. Like suppose use NumPy only, or if you are working in, I don't know, R, then use what is it called in R? I think it's there like matrix or something, R matrix. Then use those kinds of modules. Like what you have to do in that is, you have to understand like when you're trying to like when you're trying to create, suppose, a regression model or an artificial neural network in a TensorFlow or a PyTorch environment, you have to just write a single line. Suppose PyTorch dot ANN, input data, output data, and then you get the model. However, if you're using NumPy, you can just find out exactly how the data is flowing through the model, what kind of multiplications are you doing, what is the size of the different weights, what is the size of the output, the size of the input. It increases your understanding to a much farther degree. So just like try to understand it how it works once, and then you go on. Obviously you will never keep using like normal Python and NumPy to do all of your models. You should always switch to PyTorch or TensorFlow or scikit-learn, but before that try your hand at this. I didn't do this at my like at when I started, but I did it in the middle, and I obviously it helped me to understand the concepts a lot better. And so one book which you can use to do this is a book by a YouTuber called Sendex. I don't know if you all heard about him. He's a very popular machine learning and all that. He shares a lot of stuff about that. So like this, I'll share the book which he has written. It's called Neural Networks from Scratch in Python. It's very descriptive, and this book is very very descriptive. Like it has beautiful images of how the thing is going on. You all can obviously find a PDF somewhere on the internet, as we often try to do. This is available, and this book like takes you through the entire process of creating an ANN, and it explains every step of the way. It's not like it says you do this then do that, as most tutorials do. It says do this then do that, then your model is done. But this book goes through why are we doing this and why should you do this. And he also mentions what are the different things you can do at a particular junction. It's a very open-ended book, and you can use it as a reference point to start your ANNs or neural networks journey. Yeah. Okay, so what's next? Now, after creating a neural networks from scratch, you all like you all should. There are like different choices. You all can use TensorFlow. You all can use PyTorch. You all can use. I guess not all models are available in scikit-learn, but the simpler ones, like the machine learning ones, are, and the ANN is there right now, and CNNs are also being introduced. So yeah, these three, and there's also some like fast AI, then MXNet, and other like Intel has their own framework. So there are many frameworks. Now I would suggest you all start, or you all like continue your journey with PyTorch, because although PyTorch is only a deep learning framework, however, it is so open-ended that you all can do almost anything with it. Like it's basically just NumPy with some additional features, and plus the ability to use GPUs for the calculations. So why does it help? Like it like the code is in PyTorch written in a very Pythonic manner. Like it tries it makes us use loops, then list comprehensions and all that. So it increases your Python knowledge as well, and it increases your how the model is exactly training. Like how does the for loop continue? Where does the epochs like start and end? What is the implementation of the training loop? So it goes through everything in much more. Like you all have to type more. It's not like TensorFlow has a function called model.fit, and I don't like that function because it does more harm than it does good to a ML researcher in the beginning. It like we all cannot predict what is gonna happen in the middle. Like how is it gonna shift the weights? But like is it gonna shift the weights in the correct direction or in the wrong direction? Or why is the loss going at a it's dying to zero and then not benefiting our model? So like PyTorch does this very like in a Python way, and it helps us understand the world of ANNs and machine learning in a better sense. That's my opinion. So now let's discuss some other resources to start your ML and deep learning journey. Yeah, one I already mentioned. That's the the neural network from scratch book by Sendex. Another is I'll be sharing some links to some uh, YouTube playlists in the chat. So one of them is this. If you all want to learn PyTorch, then this is the I have used this guy. This guy. What's his name? Aladdin Prasan. He's a wonderful coder and a wonderful explainer of some interesting concepts in PyTorch, and he goes through a lot of the hard stuff. So you all don't have to It's just for understanding why is this, like how is it implemented. So you all can use his playlist as a reference. I'll just share this to the chat. I guess the link is gone. So this is something you all can use. And another one, to learn the theory and not the implementation, is this course from whom I am being like I am borrowing some slides and certain topics. This guy's name is Abu Mustafa, and he's a lecturer at Caltech. Yeah, Caltech, and he has some beautiful like lectures of like around 1 hour. 1 hour is the lecture, and 20 minutes is the Q&A session with the students. So you all can watch. There are like 20 lectures, and although it is a bit technical and a bit theoretical, this helps a lot with understanding why does machine learning work the way it is. And this, I think, benefits everyone who is starting out in this field, and not just people who are want to like do a master's or a PhD. Like you all should know what you're trying to do and not just apply blindly. So this playlist will help in that sense a lot. And if you all don't want to use a YouTube lecture which doesn't provide a course certificate, and you all want to learn like half of both, like half of theory and half of implementation, there is this course on Coursera by I think Michigan State the University of Michigan. It's the applied data science with Python specialization, but it is not that like heavy on the this part, but it's more heavy on the machine learning aspects. As you can see, it starts with charts and plottings and etc. But this course is highly recommended. This applied machine learning course. It teaches a lot of stuff like how does an SVM work, and then how it is created, like how like in which field or in which data will it work properly. So this course is highly recommended from my part because I have also used this one before. And yeah, these three are, and obviously keep reading. Like don't stop reading about random topics. There are a lot of what websites, a lot of websites called I think machine learning mastery and all that. Like obviously I don't remember everything which I learned in like the last 6 months. I just, you can just Google and get this guy is a very good explainer of stuff. He also has a book. Every website has a ebook or some kind. So you all can just like, you can just Google search his name, or you can just search about anything and his page will be the first one to come up. I guess people who have started working have seen this website a lot before. Okay, let's wait. Okay, so now let's like I'll just open for questions if you all have any, and we can just have a Q&A session about where should we start, what should we do, or what kind of any type of questions. I can have some 10 minutes of questions. Yeah, anyone?
Actually, I have used OpenCV for a body motion detection once. So, what's the difference between that OpenCV thing and PyTorch? Uh,
Okay, so normally in the in the field, what most people do is they use OpenCV to get, like OpenCV has some wonderful functions defined for when you want to interact with the webcam or with your like suppose what webcam or some
yes.
other camera. So that part of OpenCV is absolutely brilliant. Like that is the best. So you all can use those functions, and then the moment you get the data as a like a array, right? You take that data, you get it as a JPG, you do what? Uh, what is it called? That's read from JPG or something, and then you get that. Okay, so now you get an array, and then you go to PyTorch because OpenCV only has a certain n number of models available. But suppose you want to do something with the image you captured, which no one has ever done. Like suppose it's a custom problem, then how do you solve that problem? So then OpenCV might not help because it doesn't have that, like because it's never done. So how will some other person develop it for you? PyTorch is what it gives you an open-ended like tools to build whatever model you want to build. Like suppose you want to build a model which is half linear regression and half SVM. You might, it might not be even feasible. The like the if like if I think about it, for a second, but suppose you want to do that. Like first it passes on through a regression model, then it goes to a SVM model. So you all cannot do that using a normal like OpenCV or I don't know what's all that, like scikit-learn or something. You must use something like TensorFlow. Like that is a bit more like, what do you say, complex. Won't say complex, but like much more open-ended. Yeah, that's what I will go with.
Okay, now understood.
Yeah. Okay. So any other questions? Actually, so like how many of you all have worked with ML models before? Like I guess Protoy Chakraborty wrote something about he has worked with before.
Yeah, so I've worked with ML models before,
Ah,
primarily in the field of uh, say, image detection, like the same kind of
ah,
thing you work on, like diabetic retinopathy.
okay.
That is it. Okay, so I had a question which was related to something a bit different. So
Ah,
primarily
sure.
today we discussed about learning models, but what like how to go about things like classical machine learning models like random forest and say your KNNs and nearest neighbors and stuff like that.
Okay, see. So you said what? KNNs, nearest neighbors, and what?
KNN is the nearest
Ah,
neighbor.
right,
So
you K nearest neighbors, and what was the other one you said?
clustering algorithms and like
Yeah. Okay. So those, what those are? Now, this one was which I was primarily working on, supervised learning in using machine learning techniques, supervised
yes,
machine learning techniques. So what you're talking about is something like unsupervised
unsupervised.
unsupervised models. So okay, like let me open up some. No, okay, like I'll just talk about it. So unsupervised models are, those are used when suppose you have a lot of raw data, but you don't know what the exact classes are. Like suppose you have people who have ordered from your website in the last few years. Okay, so now how would you try to divide them? You can use, suppose, how much they have ordered, right? Or like where have they ordered it from. Now, however, but you don't know a particular division of those people, right? So you can just feed all of that purchase information to a, as said, KNN models or a clustering model, like a K nearest algorithm, and then it will just, and you will tell it, the model, that how many number of classes do you want to find out. Like I'm just describing the model, so it's not that, well, not that helpful, I guess. But so what it tries to do is it tries to find out, suppose you are saying you want to get 5 clusters, so now it tries to find out 5 points in the data, like the hyperplane, the 5 points where the most amount of concentration of points is there. Like suppose you get 5 different points in the, suppose, 6 dimensional data. Okay, like there are 6 features, so you get those 5 points. Now you try to decide, the after you have fixed those 5 points, you try to decide how far the circle or whatever threshold, like a classification boundary you're using, how far will that go from the center point. So that is done by calculating the distance of the different points of like the things away, like outside the classification boundary and inside the classification boundary, and it tries to like min max like those differences in certain way that it doesn't like cross over to another class's boundary, and it doesn't like become so small that it's just that one point. So that's how it tries to, what, like tries to optimize the algorithm.
Yeah, so that's what my question was. For example, let's take an example of something like a recommendation engine.
Hmm.
So essentially, what I'm doing here is doing the KNN problem, but in multiple dimensions,
Hmm.
right?
Yeah.
So how do I understand that whether I should do KNN in multiple dimensions or should I just put it through a deep learning model and just get it into classes? So
Wait, but you
what's
don't have the classes. If you have the classes,
yeah?
like you, if like, do you have the classes available to you?
I mean, if for example, like if it's a movie, I know that what genre the movie is. So that is definitely a class I have with me available. Like I can
Okay, okay,
classify
okay.
movies
I
into
understand. I
genres.
understand. Okay, so like you can. see what I would say, as I said in the first 10 minutes, it is more of an art than science. So what I would suggest is there is something called the elbow method, which is used to calculate the number of clusters you need. So you first apply that, and then you try to get the clustering of the KNN algorithm, and then you try to figure out, does this make sense? Like you look at the classes which it has divided in, and then you try to like figure out, does this make sense for me? And then you do the same with the ANN model. You run these both simultaneously, like side by side, and then you check what, like the output I've got, does that make better sense to me or not? And then you choose which one is the better. Like in this case, since you're using two different algorithms, there is no like an error metric which will go across all this. Like the KNN will have a different kind of an output, and the like the deep learning model will have a different type of an output. So you have to look at it in a more holistic way, like in a more what, like a human should like understand what is the difference between the outputs of the different models.
Yeah, sure.
But like that elbow method which I said, that's a very good method of finding out how many clusters you should use. So
All right.
yeah, okay. Like are there any more questions or?
I don't think there are any more questions. If there
Ah.
are, guys, just drop it in the chat box, or you can
Yeah.
just reach Srinjoy through his LinkedIn.
Yeah, surely. I guess like the LinkedIn was given in the poster which you all made, right? So if there's any questions, just you all can contact me in my LinkedIn, or I guess Facebook is also there, but I don't see much. So LinkedIn is the place to contact me. And yeah, that was it.
Yes. Thank you very much, Srinjoy, for
Uh,
this wonderful session.
and thank you for letting me present. Like this
Yeah.
is like this is a mishmash of different topics which I have been like thinking about, and so it was a good refresher for me as well, because the best you learn is by teaching other people, like even talking about it. So just try to teach other people what you have know good, nice, like you know it better, so you can like increase your knowledge about that. Anyways, thank you for having me.
Yes, absolutely. Let's
Yeah.
catch up.